All right. Welcome to the last session between happy hour and you. My name is Leo Salce. I'm CEO principal of Avantleap. I'll be talking about one of the areas we specialize, which is digital twins, and I'll tell you what that means because it's a very subjective topic. Um, just a little bit of background. I'm an architect, but also a software developer. I've been in the consulting industry for a long time, so it means that I've learn a lot about different problems from the entire life cycle. So for the past 10 years, more and more on, working with owners that have, just the asset management side, the operations, anything around the whole life cycle. And I'm pretty passionate about talking about technology, how, it can actually help elevate a practice, and then how can it provide value. So a little bit about what we do. We've been around for 5 years. We're based in California in the Middle East. What we do is basically partner with companies that want to advance their practice, digital practice. A lot of that involves digital solutions. So it means developing tools that connect, automate, or implement some level of AI. And then the digital twins, which talking about the future, is the smart digital twins. And I'll tell you what that is. So it's funny. I talked to somebody yesterday, when you see the slide here, is we have a number of projects in different parts of the world. We started 5 years ago in Irvine and Dubai, but then you see Santo Domingo in the middle of it. Like what's common between California, Dubai, and the Dominican Republic? Nothing. So basically, there's always some personal connection that ties into why you're somewhere. But to give you, we've been fortunate enough to work in a short amount of time with a lot of different companies that are working on very diverse initiatives for streamlining the process. Again, from design through construction and into operations. What I'll talk about today is very focused on, the end of it, like after handover, asset management, operations, and so on. So what is a smart digital twin? Well, the concept is, and this is just a generated, image based on, if it's a living, breathing organism, then, what does it look like? Does it smell? Does it, can it see? Can it hear? Can it interact with people and so on? So I did have, there was no sensor for taste, but they're actually sensor for taste, where you can have chemical substances. Actually, Pringles and the companies that do. You ever heard the motto? Cannot have just one. So there are people that are using sensors for accelerating the process of consuming all this data and then streamlining sort of solutions, or at least executable, actionable items, or basically action. So there is, when it comes to IoT, I mean, you talk about sensors, but it's really anything that collects data in real time. And there's a plethora of different technologies out there. And we've been, for the past 5 years, looking at emerging tools that simplify the process. And I'll talk about that in a second. But one of the things that we always see is like, what if buildings could talk to you? And I think it's been said a few times today. But the idea is that, you have all this data. You have, you ask anybody here, what is a digital twin? And you'll have probably different answers. So the idea is that, how do you combine all this information that comes from the entire process, from the design, where you have the BIM model, the data that is collected through construction, and then everything else that gets, input into it. But then what if you then add all that real-time collection data and then process it? So if the building had a brain, what could it tell you? So the first thing is if you're sick, or if something is not working the way it should be. And then connecting. There's a really cool case study for ThyssenKrupp. I don't know if you know that elevator company. They developed a tool before ChatGPT, before OpenAI, in partnership with IBM, called Max. It's a smart tool. And for a while, they had it on the website where you see elevators talking to each other. So it's like a natural language where they say, you know what, I'm not feeling well. And then it would actually be translated into something's wrong, it's not working. So then it would actually, create a work plan so, they can do remote maintenance and so on. But what we look at is a Fitbit mindset when it comes to, integrating all this data. A lot of what we do is digital integration. So working with different solutions that have an API, possibly, that then you can connect and develop those connectors. But it's the evolution of all these tools that in the past you always heard about the same sort of vendors, Siemens, Johnson Controls, Schneider Electric. They have fantastic solutions, but the problem is, what about 100,000 square feet building or lower? It's not cost effective, and then they're usually underserved. So if you wanted to make it smarter in some capacity, then you usually target like very simple things. How can you reduce costs in energy consumption easily? Well, there's a number of measures you can implement, like lighting control, HVAC, and right there is 70% of potential energy consumption. So what can you do about those things? Look at technology that is evolving, that is easy to implement, that eliminates the cost barrier to actually, that usually most of them today have a dashboard or some kind of metrics for machine learning. We looked at it, during COVID, for instance. This is one. There's a number of vendors that can detect air quality, all kinds of, degrees of whatever you want to see in the air. But then, like, COVID, you want to test COVID in the air. You want to see if there's actually pathogens. So we looked at companies, and there are a number of sensors that can capture pathogens that are the smallest thing that you can think of. But the thing is, they're very expensive, and then you have to install every certain square footage. Anyway, long story short, with a CO2 level concentration sensor for $40 on Amazon, you can capture the same information that will be valuable to you. And then the same thing, and then you kind of correlate the way that the human body sort of performs. Like, you're looking at veins, you're looking at the lungs, the heart, and so on. And it's about seeing what's happening in real time in the building. And then what do you do with that information? So, just before that, there's a number of devices. And again, it's great because there's a gold rush when it comes to AI, and technologies are coming out that are trying to address every single process you can think of in the market. So one example, and they're all very driven, they're very specific initiatives on what they want to accomplish. Like, this is one client that had their own sensor type. They do smart glass as a manufacturer, but they do construction too. And they wanted to create something that provides more context, but then addresses the key things are kind of like what they promote as sustainable tools, sustainable products. One of them is, the glazing, can go from 0 to 100 in different tint levels. So they want to visualize that in 3D. They want to see if the building is performing, if it's safe, and if it's, healthy. So, but what does that mean? So then each one has different metrics. And then, how much does it have of a budget? So we normally work with companies that don't have the level of R&D, teams and resources. And it's about kind of having that mindset of necessity is the mother of invention. So whenever you have a limited budget or you have no budget, you get pretty creative. And then I'll tell you a couple of techniques, by the way, to accomplish things with little resources. So the whole thing is, what if you have a nervous system kind of thing, where it's a smart monitoring, and that's something that then allows you to see and integrate all this information into a meaningful manner. The challenge is, and this is the first thing. First, I would recommend hiring an intern that is very savvy, that can evaluate the market on, given the metrics, given the guidelines on what are you looking for, and then you don't have to spend on validation of what's already there. So you don't start with, reinvent the wheel. So the challenge with a lot of technologies, just whatever process it is, I'm talking about digital twins here, is that a lot of them, they can get you very far, but a lot, the challenge is most clients or most organizations, they have very specific goals. So then to find, especially the ones that are more complicated, that have the entire life cycle, design, construction, operations, but then end to end, they're going to maintain and manage that building over time. Then it makes more sense sometimes to do a custom sort of, development effort in which you plan out how is that going to be maintained, and if it's going to be more cost effective, what's the ROI, and so on. But then this is what it looks like. So this is before AI, but it was with the principle of dashboards that provided insights based on, if you were this type of role, a technician, and you only had, 30 seconds to make a decision that was really important, how deep down do you have to go on a menu? And then what kind of information do you want to visualize? Any data that is related to, again, sensing space utilization, how facilities are performing, equipment, electric meter readings, energy, usage, and then energy usage based on benchmarking. We've done a number of pilots where, it's not just, what's the last 12 months of electrical, kilowatt per hour usage, but then being able to see that in real time and then apply that to actual, specific sort of initiatives. But beyond that is like any equipment you can think of, and think about it from a modular standpoint. If they care about, we always start with like a menu of a restaurant. What do you care about? Energy efficiency, equipment operation, like, switching from OpEx to CapEx because you're very reactive and you have no visibility over what's happening. So anyway, in the end, the sky's the limit. As long as, solutions and systems that exist for an inventory management, warranty information, work order history or management, resource management, I mean, you name it, that you can connect and bring those together. There are platforms that are pretty robust that already kind of, give you all that insights, but it's about tackling the problem or tackling what is the actual business driver. So all of this is based on the business driver proposition. Like what's, the client wants to save A, B, C, for cost, but then they also want to impact specific things like if it's a hospital, patient safety, patient care. How do you translate digital twin, using a digital twin in operations and maintenance with the patient safety? Well, you can measure time very easily. How long does it take you to execute an issue, a work order, in the traditional way versus the digital twin enable way? So this is a good example that I just showed you. Being able to visualize the IoT data within the 3D environment, it provides so much context, but then you add the layer of AI and the dashboard that is dynamic, that reflects based on what you're prompting. It's fantastic, especially if you only say, what do I focus on? And we have a number of pilots I cannot show you, but with AI assistance, how powerful it is to see somebody's in front of a piece of equipment and you can tell when was the last time this was serviced, or is there what should I prioritize today? Is it under warranty, and so on. So the sensor I was telling you, the CO2 level concentration, you can drape the information in color code and just simply say if there's any ventilation issues, just seeing in red quickly. With this particular project, one of the cool things is that there were several pilots that were implemented. A lot of it was for planning for failures, some technology that could potentially do predictive maintenance because they already have a way to onboard the machine. If you're looking at chillers or you're looking at meters and et cetera. But it also helps for planning. Like if they're planning a new retail space in the facility, then they can see the amount of load, the type of loads that they have. This was a really cool use case. It was basically, there was an algorithm developed for lighting control, sunlight control that was based on 36 different lux levels, where based on weather conditions, automatically the indoor lighting is adjusted. And they perform a simulation where they projected about 15% savings in energy costs. That's pretty significant. So then what they're using the digital twin now today is to benchmark that information in real time so that they can actually see what's happening and then, be able to confirm. And if you're looking about, if you think about LEED, and I was just doing a talk last week at AU about streamlining LEED certification. LEED, especially for existing building, requires recertification and proving, and there's a lot of things that are beneficial about using live digital twins, is the data that you can use to actually validate. Somebody mentioned that, evidence-based intent. So basically here, you're not lying, it's data transparency. And the new LEED version 5.0 is gonna have a lot of emphasis in data transparency. Like you actually have to, show me what's happening. So there's so much potential, and it's about using what's already there. Don't reinvent the wheel, like training a computer vision model to detect, whatever. Anything you see a lot of the construction safety equipment thing, but like for anything that moves, this is fantastic to see, a quick interaction of how a warehouse or a factory is operating, especially because anything that involves production for equipment or whatever, they count by the minute when a machine is down. So if something where, the oil and gas has been in the forefront, by the way, we've done some projects or proof of concepts with Shell in Doha, and that's where they kind of pilot a lot of the new technology that they're going to implement. They have a lot of things that they've done in terms of computer vision to detect inspection on areas that are very hard to reach and very, very dangerous. So there's really, you've seen a lot of these things, in the past sessions, but I think it starts with what is the problem that you're trying to solve? There's a lot of challenges, and a lot of it is solved by trusting the data. And then, of course, garbage in, garbage out, you heard that. But then it's impressive that a lot of it is this. You ask today, any organization that has an operation asset management group, can they efficiently and effectively receive and organize and retrieve facility lifecycle asset data everywhere, anytime, anywhere, on the office in the field? 90% chance? No. So it starts with this, which basically is, we work with different engines, from the Autodesk Viewer platform services to Unity, Unreal. We test a lot of different ways of visualizing the data. And the idea is, what is it that you're trying to show? It's about integrating what's already there. A lot of times, every company or every organization has different systems. And most times, they're not going to change whatever you say you're going to propose. Why they're going to drop, their work order maintenance system or whatever they have in place. So it's about assessing and being sensitive to what's there. And then once you have that, then the idea is, all right, already 15 minutes. The idea is, you trying to control? Do you trying to monitor? Do you want to try to get insights? And then are there tools that can allow you to achieve, the things that you want to do? So in this case, it was a cool space utilization feature. Actually, place. Anyway, it's about finding people. We've done a few number of projects where how do you address privacy? So there's sensors that don't show your face. I'm sorry. There's cameras that can track, who's there, if it's an adult, if it's a woman, if it's a man. There's all kinds of technologies that can allow you to see the space. This one was more like a prototype for using your cell phone to track where somebody is, and then you can in the app find like where is Mark, and then it just shows you. So start with the problem you're trying to solve. There is, and this is outdated, it's like a year old and it has a lot of stuff missing. It's probably 10 times larger today. Everything that you can think of in terms of processes on the design side, from sustainability analysis of any kind to documentation, detail generation, and then model generation and so on. You've seen a lot of that. But then once you consider the whole life cycle, it's about what area do you want to focus on, and then not try to reinvent the wheel. And so sustainability-wise, there's a lot of tools that have been there in the market for a while. Some have been emerging with some AI capabilities. Some are strictly AI powered. There's a lot of smoke and mirrors. So my suggestion is there's different ways you can approach it when you don't have a large team in-house. So the experimental solution approach is you have to have somebody in-house that can kind of test all these things. We had a number of people that we hired that's all they do. There's basically, how can we have a low cost effective way to use, train GPT models that can be used for lead, for validation, for anything, and then combine all these different, models, and then see if you can deploy them on a server, on a computer, and then how fast and accurate. And then we've been testing our own things. Every time we develop a tool for a client or a solution, it's like, what? There's so many ideas that we have that maybe we just like start prototyping. So then like, can we use this on a local machine for model and documentation? And then can we use it for, having a chatbot built on a whatever tool, whether it's Revit or Forma, and then ask information about sustainability, like, how you already sort of perform tasks within the model, and then you ask questions specific to carbon reduction and so on. So again, this is just showing some example. The POC experimentation is really good because, going beyond AI power visualization, which is basically, we had a guy that developed this in a week, and basically he combined like 13 different diffusion models. But then the idea was, can we go further? I mean, there's a lot of competition. Well, there's a lot of companies that are doing this kind of thing. So can we use the image instead of having a model to actually have segmentation, and that segmentation give me some data from the model? So it means I like to get, initially this was the idea. You can take a picture from the mobile device using the app, and then you can kind of get some sustainability features specs from it. So you can see, what kind of, what element is in the image, then what kind of specs of materials they have. And then this is the approach that I would recommend. There's a number of hackathons, and I'm only showing this because our director of AI won first place last week on the Autodesk University one, and it was great. The problem is, they had a problem outline, is that the time that it takes to do research material, generate the material, generate different options for embodied carbon, and then connect it to a real database with the metadata, and then use AI with the diffusion model. So in 6 hours, 5 hours, they develop a stable diffusion, Dynamo script that connected the prompt-based generation of the material. They automatically created a high-resolution image, connected to Revit, and then they extracted all the table and then have a connector for material 2050. So all the metadata from the embodied carbon is already there. So in 5 hours, they already got a solution, but it's driven by a problem. So they wrote ahead, just one more minute. Everybody is going to, well, not everybody, but a lot of people, including us, we're looking at how do you blend this computer vision, all these things that I just showed you about collecting data in real time. You're looking for a Jarvis. And if you don't know what Jarvis is, it's the AI from the Avengers, from the movie. And eventually, one of the things that will happen is there's a lot of interaction about information that you retrieve. There's a lot more voice command integration. So you're going to see a lot more kind of transitioning from the traditional, dashboard. Or you can, get to this kind of level. There was a Terminator 2 soundtrack, but they didn't play. But in reality, so what I just showed you, that there's going to be, talking about the future, short term, there's going to be an asset digitization acceleration. This is fantastic because it's the #1 roadblock for a lot of owners to address going into this methodology of using digital twins for handling lifecycle data. So there's all these tools are coming out. Some of them you saw today. These days, we've tested some things with the Nerve and some of the NVIDIA models that they've created that are available for free. And the results are great. And then there's some commercial tools that are there for classification of point clouds to address the scan to BIM. But eventually what's going to happen is you might not even need the scanning. Just being able to use multiple technologies like AR and then be able to take a picture and then within that picture identify what's there. We've been testing like, hey, can you identify what's there, but then see, give me information that I can validate, like embodied carbon. Like eventually you'll have dimensional context, by the way. So then you can see from a few images how much square footage of a particular material you have. Just for example, without any modeling. So to wrap it up, everybody talk about embracing change, but there's 3 A's for healthy change. Everybody knows? You probably heard it. But if not, awareness, acceptance, and action. The question is, if somebody asks you, Netflix is going to go out of business next month, will you believe it? No. But if somebody asked you 10 years ago that Blockbuster was going to go out of business, or Kodak, or BlackBerry, you would say, you're crazy. So anyway, embrace change.